This has been awesome so far. We're here in another MLOps community meetup, and I will do a shameless plug for the first 2 minutes. And there are some announcements that we've got. The first one is that we have a Slack community. If you all are not in it, I'm not sure what you're doing, because you should get in it as fast as you can. I'm going to drop a link to the Slack community right now, and you can go ahead, jump in, join us, start commentating, continue the conversation. You'll see a lot of great and smart people in there answering questions, lots of people that are much smarter than myself to answer all of your MLOps needs. So if you like MLOps at all, please join us. And if you're already in there, cool. Let us know what you think of this talk in the Slack or in this chat. The other thing is, we're going to have Luke and Gavin give presentations today. It's a little different than my podcast style interviews, which is awesome in my book because I get to do less work. But if anyone has any questions, we definitely encourage you to throw them in the chat or the question and answer section that you have in Zoom. And I'll interrupt them when the moment is adequate to ask them these questions that you're throwing in. And I think that's about it. Any other shameless plugs I can go for? We're on Twitter, MLOps community. We're on YouTube if you want to see all the old ones, all that good stuff. So without further ado, I think we should hand it over to Luke and Gavin to get this ball rolling.
Great.
Thank you very much, Dimitrios. Great introduction. And just to add to that shameless plug, the MLOps community Slack is a great one. It was funny because yesterday I was in a different Slack that's kind of started off, and they're kind of having growing pains because they started very fast, and there was some feedback about how vendors should behave in the Slack. And I started quoting Dimitrios's rules from the MLOps Slack, saying how great it was. And then I scrolled up and he's about, 6 places above me. And I'm like, oh, he's actually here. So it was a shameless plug that he then saw. But, it really is, because it's just a great place for professionals and enthusiasts to chat to each other rather than lots of people marketing to people and try to sell them stuff, which makes things kind of miserable.
That's it. That's what we're going for. And you have been a upstanding citizen of the community. And you earned your stripes by sending me a video of you. And so if anybody hasn't seen this video, I'm going to actually go grab it while these guys are giving their presentation. But Luke sent me the video. I asked everyone in the community to send me a video at the end of the year and give us like a little short description of who you are, what you do, where you're from, and what you like most about the community. And Luke sent me this video, and it's like, MLOps community, no. And then he cuts it off. So it was obviously one of the wrong takes, and he sent me the wrong take, and it ended up making its way into the final edit. So then I decided,
very embarrassing. I emailed him and said, no, here comes a proper one, but
yeah, once I saw it couldn't be unseen. So then from there, I realized, wow, like I felt kind of sorry for doing that to you and throwing you under the bus. And I figured we might as well get you on here to talk about Git for data.
There you go. We have no shame. One of the things that you'll notice during this meetup is that I'm from Ireland and I speak way too fast. So hopefully everybody's able to understand me as I go along, but do stop to ask questions at any point if I'm speaking too half-assed or in too heavily accented English. St. Patrick's Day is coming up, so my brogue is getting thicker. But so I'm just going to go ahead and share my screen. I know this goes out as a podcast as well, so I'm going to just try and speak to it as much as possible rather than just rely on the slides and the visuals. Perfect. So hopefully everybody can follow from different side. So, this is the point Dimitrios is making. You wanted Git for data. The world wanted Git for data, and it absolutely got Git for data. There is Git for data coming from all different sides. And this is the spreadsheet that he was talking about. These are just the free and open source Git for datas. that are out there. And I shared this in the MLOps community. I contributed to it as well, but it's Justin Cormack's document. He's the CTO of Docker, and he follows all this stuff very closely as well, obviously, because a lot of these tools rely on Docker. And so I think we're all going to have to take a deep breath, because I'm going to try and run through what all these different tools do and just give us a little snapshot of what Git for data and the breadth of Git for data it could be. And so this is kind of the origin story of Git for data. There's a bunch of questions out there where people are saying, I want something that's like Git, but for data. I want to be able to do diffs. I want to be able to do merges more intelligently on CSVs or on other data sets. And that's kind of what the beginning point in a lot of this cycle is. So you can see that's 7 years, 8 months ago. So it's a good while ago. And that key improvement that people are looking for is the diff merge more intelligently. And a lot of these projects on this spreadsheet, which I'll share around in the community, in the Slack group afterwards again, some of them are active, but a bunch of them are dormant. So there are both living and dead Gits for data. So what is a Git for data? Like, what's the question here that we're trying to ask? Like, what qualifies as a Git for data? Is versioning data enough? I mean, that seems to me like it's probably not enough to be Git for data, because Git is so much more and there's lots of data versioning tools out there. Or do you need Git-like workflows and branches? In my opinion, you can't really be Git for data without a bit more than just simply versioning data. You need to, allow for that coordination and collaboration that Git facilitates amongst software engineers, and really bring that to ML engineers or data scientists. There are lots of platforms out there, and I mean, I think everybody who's in the MLOps community will realize that there's a silent war taking place between end-to-end platforms and tools that you can make up in your ML flow. And there are a bunch of kind of end-to-end platforms that say they're GitHub for data, but to me at least, they typically haven't really understood what Git is and what Git for data is, and they go straight to trying to be GitHub for data without ever getting that Git right. And obviously, we fall on the side of that debate where you get the best tool for the job at each stage of your ML ops or ML pipeline, rather than just dropping everything into a one-size-fits-all platform. And I think probably both avenues have different use cases for people at different stages in the MLOps journey. I just hate to think that people are getting stuck in an end-to-end platform and then not able to get out and sample from all those great tools out there.
And Luke, you probably are going to talk about this, but just the first thing that comes to my mind is, why can't we just use GitHub? Do you talk about that?
I do.
Further slide. All right, then I'll let you get to it. Yeah, I don't want to ruin your flow. Sorry, man.
Yeah, well, I mean, I suppose that's the kind of why data is different from code as well. Data code is effectively text, and data, there's just much more. It's bigger, and from our mind, you got to be able to query it if it's bigger. It's harder to diff as well. Anyway, I will get to that. So here's the 4 big buckets that I decided there are of Git for data tools. And these are divisions that are hazy on the fringes and unclear on the fringes, but I think they capture the essence of the 4 different types of approaches to Git for data. So there's the versioning layer. Often they're proudly not a database or a server, but then limit themselves to some ecosystem, either versioning S3 buckets, Google Cloud, or Postgres. Then there's data catalogs, of which there's a bunch, and a few of those call themselves kind of Gits for data. And obviously data catalogs are a very important central piece of lots of data infrastructure and data management setups. Then there's the data pipeline versioning, which obviously is a big piece in the MLOps world. And there's some excellent tools doing that. So it does exactly what it says in the tin, as I say. It reproduces the entire pipeline, and there's really interesting and successful tools there. And then there's the version databases, which are the, append-only databases with version control features like branch and diff and merge across both schema and data. And that's an important point for those ones at least. So let's start at the top of this list and just have a quick run through what they all do. So datahub is a dormant project, but it was a hosted platform for collaborating and making sense of data. So it's a GitHub for data type idea. So one of the interesting things about this is the guys who made it went on to found Instabase, which is all about solving complex document workflows. And looks like they took a bunch of the good ideas around Git and GitHub and then applied them to another tool. So there's the guy. He's kind of well known on Twitter and stuff as well. So they've taken a kind of good idea from GitHub and then turned their platform into a specific GitHub or Git-like tool. Okay, so here's these litetree fellas. These are blockchainy. And there is a kind of big blockchainy sub-trend within the Git for data world. And there's another database who's not on this list called Flurry, and they actually are a mutable version database that is built on the blockchain. Now, our fundamental difference of point of view is that the blockchain makes things slower, and you don't want databases to be slower, typically. So these guys are, they're based on the SQLite. I always find that word quite strange to pronounce. Like, is it SQLite, SQLite? Do I have to double pronounce the L? Anyway, the SQLite engine to support branching. And that branching is really for blockchain implementations. And they do have an ongoing service, even though that project is dormant. Okay, so noms.
Sorry to interrupt. On that, what would be the benefit of it being blockchain? Like, why did they want to do that?
Well, if you wanted to do auditability, I mean, there's some value in having the blockchain. So if you're in some sort of high assurance banking or something along those lines where you need to have an audit trail of all of the changes that are made to the data, then it's quite a good idea. You probably are going to have less data in this, whatever it is that you're constantly auditing, because it's going to be a little bit expensive to do writes. But yeah, it does make sense in certain use cases.
Yeah, because we kind of do the same thing a little bit. Like, we have a layered structure and that's content addressable. So you can see exactly what the parent and the child of any one layer was and kind of prove it out to say, like, these guys are clearly linked together. And noms is another good example of this. They use litetree, and they're a decentralized database which mirrors Git very, very closely. And they're all about sync, and they're fully decentralized, and they use litetree structures within the database. And they're something of a granddaddy in the world of Git for data databases. Gavin and I actually had a word with the founder recently. They're actually defunct now. They've moved on to another project which is called Replicache, and it's for real-time sync for a backend stack. But the guy's a really nice chap, and he actually lives in Hawaii. He's left California, has gone to surf in Hawaii, and set up this other company there. So we were kind of, I'm here in Dublin now in the middle of a zombie apocalypse. And he was just coming in from swimming in the Pacific, so we were a little bit jealous of how our paths had diverged. Anyway, these guys are very interesting again because these next chaps called Dolt and dolthub are actually built on the back of noms. So dolthub took noms, which is an open source project, forked it, and then built out Dolt on the back of that fork. So they actually took a MySQL query engine and brought it together with the graph database that is noms, and so that you could have an SQL queryable version control database. And they're quite developed and quite cool. The CEO's a nice guy, and he's the former head of engineering at Snap. So he kind of came out of Snap with it and kind of saw their sort of problems in there and brought it out. But they've gone for the data marketplace type approach. So they have all these data bounties where you can improve the data sets. It's a little bit Kaggle like in the way that they've approached it. So you're starting to get a picture now. There's like guys coming at Git for data. Everybody says they're Git for data, and they're all different things. So dotmesh, the guy from dotmesh is well known in the community. I think Luke,
RIP. Actually, it's just a quick side note. dotmesh is what the last company that I worked for, .science, was built on top of. And then that went out of
you
business.
worked for them, did you?
Yeah.
Wow.
That's how the community started, because Luke wanted a community. And so I was tasked to do it. And we started interviewing people all those months ago.
Oh, fantastic. Yeah. So how many meetups has there been so far?
This is the 53rd meetup.
Okay, so 1 year and a week. That's perfect. We're the first one after you made the 52-week turnaround. And so dotmesh, is a Git-like CLI for capturing, organizing, and actually I could probably hand over to you, Dimitrios, to give the introduction to this one.
Give the whole thing.
Yeah, but they unfortunately shut down in May of last year. But as Luke said, and I have a little snapshot from the MLOps Slack, where he said that the dotmesh actually lives on. And it's an open source version of dotmesh that's now available on GitHub, and it only has 3 stars. So I'd encourage you all to go and give it some stars, because it needs some love, especially after closing down last summer. So yeah, but they were very collaboration and deployment focused. So really an MLOps platform, .science was, and really focused on those sorts of use cases. So Meltano is a GitLab ELT for the data ops era. They kind of get into this ELT versus ETL debate, which is, a big one within anybody who's in the data management world. But that's, loading first or transforming first. I think Snowflake have come into that with 2 very large billion-dollar feet on the side of ELT. So they're open source, they're self-hosted, they're CLI first. So they're all about containerized pipelines as code, and version controlling them. They're very much, hey, you've got a machine learning pipeline, it's code, and then they're built on the Singer and the DBT ecosystems. So they're again, I actually don't know this tool as well as some of the others, but while I was looking into this, I was checking them out, and they're very cool. Even though we're kind of from a competitor, we're from this world, and you're looking around the other tools thinking, wow, actually, I could use that to do some cool stuff. So then you have these guys are called gretel-synthetics, and they're about synthetic data generation with neural nets. Everybody, synthetic data generation is kind of a coming thing, and they're very much on the data catalog end of the Git for data spectrum. Then we have Grist. So Grist is for comparing tables. This is very much like, Git. It's all about, diffs between tables, but they use it in order to power a spreadsheet. I'm always a little bit suspicious of spreadsheet tools, because I like Excel. I know maybe that's not most popular view, but I like Excel, and I think my grandchildren are going to like Excel, or at least have to use Excel. So a lot of companies come along and say, oh, Excel's useless for this, this, and this. You should stop using Excel. But people love Excel. I don't think it's ever going away. So I'm always a little bit suspicious of them. DVC. Now, I think that if there's anybody who's in the, I noticed actually when Dimitrios posted this meetup to LinkedIn, one of the comments directly below his thing said, I was sure this was about DVC. But that's because they're synonymous. They have become, within the MLOps version pipeline, they've become synonymous with Git for data. And they're built on Git. They use all the Git semantics, and they allow versioning of large files. It has some problems because it's not a database. You can't query diffs. You can't do a bunch of other things like that. But it's easy to get started, has a great community, and already has secondary tools that are being built on its open source framework. So DAG's Hub is built on DVC. So like it's just very MLOps as I say. So then pachyderm, our good friends Pachyderm. We are brothers in arms with Pachyderm because we're both members of the AI Infrastructure Alliance. So we love the elephants. And you know, they are a big one in the enterprise data pipeline versioning world. I think a lot of us will have seen their tool, will know about them. And they're backed by Benchmark, which always gives you a kind of ring of success in the startup universe. But again, it's, you know, it's pipelines that are versionable. You know, they model. They do kind of pipeline code running on data and then model that as a sort of merge commit, allowing for versioning concepts like branching and lineage across your data pipeline. And it's containerized and it works quite well, and it's all, you know, put together fantastically. These guys I didn't know very well either. Query, so they're a data catalog and version control system built for the distributed web. So they're all about data discovery. Version control keeps your data available to be discovered, and then built on the distributed web, so it's everywhere. It's published simultaneously everywhere. Yeah, so they're GitHub and Git for data working together. Then Quilt, these guys have been through a couple of iterations. I think they were a YC company. So now they really are just a data portal for AWS S3. If you got an S3 bucket, they specialize in data versioning and discovery there. I actually went to their website before this talk and had a look for my name, which is Luke Feeney. And I found a friendly looking coder called Joseph Feeney, who works for AWS in Seattle, who's actually a native of Oregon. So, you know, it has that sort of quick and deep discovery across S3 buckets. Then Keepsake, a Python library, they do, you know, again, they're on S3 or Google Cloud Storage. They fall into that kind of layer on top of a different ecosystem. And then Irmin, I mean, this is a library built on OCaml. So I'm going to let Gavin talk a little bit to this one, just because he used to be an OCaml master, for anybody that knows that particular language.
Well, actually, I was just looking through the source code for it, but I haven't gotten too far deep into it. But I was a really big OCaml fan. And I always wished it had a little bit more of a following so I could get a job doing it.
But again, they're a distributed database and they're built on the same principles as Git. And, you know, they're very open source in a sense that they, you know, are a proper open source project with a broad range of contributors, don't really have a kind of, you know, a commercial open source element that's sitting on top like a lot of the other open source tools. These guys are a genuine open source project, but they're, you know, I don't know how many OCaml coders are out there. I mean, maybe we could do some sort of poll at some point.
Yeah, if anybody out there knows, please let us tell us in the chat or leave a comment if you're watching this in the future. OCaml.
Yeah,
wow.
It's a great name, isn't it?
Yeah.
And then I think finally we come to LakeFS. They're the last one on that list. TerminusDB is obviously on there as well, but I'm going to let Gavin talk about that after I finish up. And they're a versioning layer for your data lake. Again, like this is a really cool project and product that allows you to just have much better control over what's in your data lake. And it's on S3 or Google Cloud Storage, and you know, people have these buckets and they have no idea what's in there, and it's not versioned, and who knows what's going on. And this guy just allows you to, you know, build something repeatable for your data lake operations. And I think there's a lot of people in the MLOps world who are presented with these, you know, data engineering challenges as much as machine learning engineering challenges of kind of like, what's in this giant bucket and how am I supposed to, you know, work out what I should do next. So those are my 4 big buckets: the versioning layer, the data catalogs, the data pipeline versioning, and the version control databases. So each one of those falls into one of those buckets. And I think I'm kind of getting to the end of my piece, so I'm going to breathe and pass over to Gavin. How do I stop sharing? Oh, there it is.
Sure.
There you go.
Thank you.
And Gavin, you've got a good answer for why not GitHub.
Why not GitHub as a, okay, so maybe we should talk about that for just a minute before I put this up. So, I mean, GitHub, actually, you can do quite a lot with GitHub just as it is now. And since a lot of ML operations are just using CSVs, CSVs with GitHub can be feasible depending on the scale of the data that you have and precisely what you're doing with it and what you are actually trying to version. The thing is, like with code, I mean, a line of code, frankly, isn't even really the best way to do a diff for code, much less other things, but that's what we have right now. So right now our diffs are on the basis of a line of something. And that's maybe not the best sort of unit for code, but it's workable with code because code's generally quite small in terms of the scale of this. I mean, unless you're Google, who has a billion lines of code or whatever it is, you probably can deal with the diffs quite easily. Once you start getting into larger amounts of data, then a line is there's a couple of problems. One is that if you have binary data, then that's not so great. If it's CSV, you're grand, probably it's okay. But you also, if you have a CSV, if you're just changing one cell, is that the same thing as changing the whole line? Should you be versioning that? It's not clear. But then when you start having large numbers of changes in the CSVs, then it becomes a real problem because you can't really see, you can't just display all of them, and you can't figure out exactly how to do a merge or some kind of other complicated operation unless you can query the information in the data that has changed. So I'd say that's the main one. But actually, in my talk, I'll get into more of the sort of details of why you might use Git or why you might not want to use Git in terms of large scale data manipulation. So
Nice.
Just,
and I know there's while you're sharing your screen, I guess closely related to this, right, is like Git for Jupyter notebooks or Git for that kind of thing. And Jupyter notebooks don't really, they're kind of famous for not holding up well with GitHub or Git. And it's also another point of debate in the community where people say, well, just don't ever use Jupyter notebooks. If you're thinking about taking it into production, don't do that. But a lot of data scientists love Jupyter notebooks. So there are a lot of these pieces to the puzzle. And I like, Luke, how you broke it up into these 4 buckets. And you said, here's what we're looking at, and here is how people are attacking this problem. So cool. I see that and I see you have ZFS already open. ZFS is what dot science or dot mesh was built on also. Just quick little side bit. So nice. You're going to go into ZFS, or did you share the wrong screen?
No, I shared. I was just trying to get this on full screen, and it wouldn't let me full screen it after I'd shared it. So I have to reshare.
Here we go.
So
share again.
Share
again. Let it out. So yeah, I don't know if either of you had any comments on the Jupyter Notebook side of thing, or Git for Jupyter Notebooks, or how to version Jupyter Notebooks.
So we have a Jupyter Notebooks integration with TerminusDB. So that's definitely the best way to do it.
There we go.
But like we see that problem as well. You know, we that data engineer problem. So we have a kind of like I have a psychological breakdown between data scientists and data engineers. And my feeling in general is that they're just very different sorts of people. And that's the kind of underlying piece about data scientists and why they're happy to use Jupyter Notebooks, because it's about investigation and never really about production. And like, you know, data engineers and machine learning engineers in general tend to be software engineers primarily. I mean, obviously there's a bit more of a mix there, but then data scientists typically are, you know, come out of physics and other places like that much more regularly and have a much more scientific, whatever that might mean, perspective. So they tend to be not so focused on things being neat and tidy and concise, and much happier for things to kind of balloon out. And you get into all these kind of tensions between them. But we've definitely tried to overcome that by integrating a proper database or Git-like database backend into Jupyter.
Yeah, great
Anyway,
answer.
Yeah.
I'll let Gavin take over because I can talk forever, unfortunately.
I came out of the physics community, and I was working in high energy particle physics on statistics, and I saw some of the most terrifying code that I've ever seen in my life during that phase of my life. Physicists might be very smart people, but they can write some really terrifying, messy Fortran. In any case, yeah. So in terms of like what I think the future will be for code and diffs is that there's going to be much more semantic content. So like abstract syntax trees are going to be stored in diffs that way, and it's going to be more robust against diffs messing things up, and you'll be able to have more sort of object content. So things like Jupyter notebooks you can repeatedly move back and forth between diffs. Anything that has sort of a binary format now, or a structured format that isn't really lines of text, is a bit of a hassle in the current universe. But I think those problems are soluble.
Great point. And maybe before we jump into this whole thing, I see there's a question coming through in the chat from Ron, who's asking, what about gitdifs with gitlfs?
As a solution to the problem of large scale diffs?
Yeah, I think that was when you were talking about the large scale diffs.
Yeah, I mean, you can use there are tools that help you with that, and like DVC also, like they work on pretty large amounts of data. It is possible to do various approaches to scale up the amount that you can do it with. So as somebody who worked in ML shops that did not use Git, and used just CSVs that are coming down the wire, and then had no sort of visibility of what was being changed when, and no repeatability, I'd say you're much better off trying to see if you can just use Git. And if it turns out that you have scale problems and can't provide sufficient workarounds, you might have to do something else. But at least that's sort of a minimum barrier for a lot of cases. I'd say you're better off there.
And you said something really interesting just there, that I think it's worthy of taking a step back and realizing why we even use Git for software, right? Like, why do you even want Git in the first place? And it's so that you can have that lineage and you can see what's going on and you can have that visibility. And so a lot of that can sometimes get lost, and you get into these trying to fix these little problems or trying to do these little hacks or workarounds, and it works all right, and maybe you get a little bit of what you're looking for, or it does one thing, but you don't get that full visibility and you don't get that lineage that you're looking for. So I think that's a huge point that I just wanted to harp on real fast.
Yeah, no, I totally 100% agree. I mean, there's so many things that can get lost in the process of, especially with machine learning, there's so many things that are varying. It can be very hard to remember even what changed or why things changed or why you're getting better results now and you didn't previously. And if you have those things tracked and you can go back in time and see what happened, then you can really remind yourself, or you can find out things about the process. And it is quite possible to end up in situations where you start a new technique that is maybe more, correct for whatever reason, and then it turns out you get worse results, but you don't even know it because you haven't been tracking all of the results that you've been getting. And so sometimes, even that can be lost. So there's a lot of things that are beneficial about that repeatability. I think that's a really strong point. It can also make you fearless. So I think that's one of the big advantages of Git is just the ability to be fearless about change. So you can really forge ahead, do something totally different, and find out you screwed up, and you just go back, and that's
it's easy to roll back.
That's
and
it.
As a side note, for the next time we do one of these, we can play a drinking game, and every time we say Git, you got to take a shot.
That's the
kill
St.
the whole
Patrick's Day
audience.
one. That's the St. Patrick's Day one.
We are saying git so damn much in this talk, and it's coming from not only just the git like GitHub, but also git like GET git. So if English is not your first language and you're getting confused here, I'm sorry about that. And if you are on European time and it is at 6 o'clock for you, then feel free to grab a drink. All right, I'll let you go, Gavin. I've been stalling you for long enough. I'll let you get on with it.
Yeah, so I'll try to be quick because I have a few slides here. So the first thing that I wanted to say is that, okay, so why are we storing structured data in the first place? Well, I think most people who are doing machine learning, they have an idea about why they need their structured data to be structured the way it is. But like a lot of the processing that I did personally using machine learning has been just sucking in CSV files. Now, I also have used relational database management systems in order to get the information, but a lot of times you just do an extract from that and then load it in and do some processing from that position. So what is structured? Structured is sort of it can vary from everything that has a database that has a strong schema to a CSV, which is really fairly unstructured data. It's structured to some extent. It has like spaces between things or commas or something separating values, but it's not typed in any way. And so there's a lot of variance in what that is. So structured data is valuable, and the more structure you have, it can add value. It can get in the way sometimes when you're trying to get things done, but it can also add a lot of value. So if you know what something is, then you can marshal the type appropriately and avoid problems in a lot of cases. So proper curation of data is something that is sort of underappreciated, I think. But I think a lot of machine people who do ML know that most of the time in actual processing time goes into the curation of the data, cleaning the data, marshaling the data into the appropriate type, and then getting it into whatever algorithm it is that you're trying to do labeling or categorization with. So that curation is valuable, and we should try to make it so that it's as easy as possible to retain the valuable information from that as possible. And so if we can move to a situation where we ingest quickly from really structured data, we're probably in a better situation. But like right now, data is really, I think, still in the dark ages, and the whole process of pipelining is pretty primitive. So a lot of core data that's used is in CSVs. People like repeatability is really weak. So like in really good houses, like people have done a much better job. Like I think in the last 5 years, there's been a sea change really in terms of improvements. But like go back 5, 6, or 7 years ago, when I was doing more ML and less database engineering, it was pretty terrible. There was a lot of, there was no versioning of anything for a large amount of the tool chain. So in terms of structured data, Git is not always the best situation. So as I said before, it can be awkward to store things as lines of text sometimes, and it doesn't necessarily scale brilliantly. So it's handy if you have structure and discoverability. And by discoverability, I mean the ability to query. So if you can query the data, then you can make decisions about data that in terms of what is added and what is subtracted and when you're doing merges. And that can be quite difficult if you don't have a query language to do it. Now you can do it with various tools, including grep, but it's easier if you have a query language to do so. The other problem that we have is the databases are quite awkward. So like databases give you a lot of structure, and they can deal with a lot of the problems of like type marshaling, etc. It's not always so easy to obtain the same type into your ML processing system, and that's something that I think is going to have to be improved over time. But they're awkward in that they tend to be quite centralized. So the people who are using the database to gather the data often have very structured rules about how the data is put in there. And if it's production data and you're a machine learning operator, oftentimes you might want to update or change or make auxiliary data go into that database. And sometimes that means you have to set up your own, or you have to have multiple databases, and that can be complicated. And so that's centralization can be an inhibitor here. I think so. It's over centralized databases can be kind of difficult for us to work with. So I think that managing data appropriately really comes down in a lot of cases to collaborating effectively. And that's, I think, really where Git did something important and separates it from previous revision control systems. So, I mean, I've been using revision control for almost the entire time I've been a programmer for a very 20-something years. But the Git changed things really fundamentally from previous ones, and that was because you had a sort of multi-mastering, shareable version of the data, and it really improved things because you weren't just all trying to check into the same repository. You had a separate repository. You could move data back and forth depending on the state of things, and that really was focused around collaboration. It wasn't just the revision control aspect, it's that push and pull, merging from multi-nodes. That's what really made it different from something like Subversion or, well, I mean, there were extensions to Subversion that did some of that, but Subversion itself didn't, and previous CVS and others were even worse. So collaboration's key, I think. The second is, we talked about it just briefly earlier, it's the provenance, so the ability to know what revisions happened in the past, and authorship, which is also sometimes useful because like it can be useful to blame people, but it's also useful to know who to ask why something is the way it is. And if you can go and ask them, maybe it doesn't really come down to blame so much, but like knowledge, tacit knowledge might be in there, and you can figure out who to extract it from. And then safety, that gives you that fearlessness, the ability to do rollback and branching as one of the ways of being fearless about change. And I think that's really, really key. And then another thing that I think has not really come fully into the data world that really needs to get there is like CI/CD pipelines in the way that we do a lot of our continuous integration, continuous deployment for software. So we've really changed the software development process 10 years ago was very different than it is today. And today when I check in, there's like all kinds of things are happening. There's a linter that's running, there's benchmarks that run, there's some kind of build process that checks to see if everything works and then runs a bunch of tests. And then that can cascade down to another branch that then is like for checking, some sort of canary or, some sort of test development or a beta testing environment or something like that. And then from there to master, where you actually deploy it to the world. And that kind of movement from various different stages along the way in the data world is still not really there as much as it is for CI/CD for code. And I think that really is something that we need to be looking to get better at, because like you can't just always be mucking with the data in the production server, and you need some way to be able to have the test so that it has the kind of data that you need that's going to run in production. And in ML, there's a lot of times where you're doing experimentation, you're doing some kind of test to see if something is going to work well. And then once you have it, you want to kind of roll it out to an environment where you can maybe A/B test it or something like that, and then into production where the algorithm's actually used by people live. And that kind of cascading would be really handy if we had that also in the data world. And then in order to do that, you need distribution. You need to be able to do things like push, pull, clone, and merge, because you need to be able to pull information so that you can have the live information that you need to do the training, et cetera, and not have it on a production database when you do the updates, et cetera. So I think that those are the kinds of problems that we need solutions to. So what would the difference be for something that's sort of built for data rather than built for code? So what would a Git for data want to have? And I think that these are the things that I think should be in a Git for data. So I think you want discoverability and schema. So you want to be able to have queries so that you can do easy retrieval of data, because data is much larger than code. So you don't necessarily want to take everything all at once when you're looking at it. And you want to be able to update it programmatically, not just by going in and editing text lines. You want to have some way that you can add thousands of things to it in various different ways and maybe merged into the same thing. So like a CSV, they have different, like you might have one CSV, you might have another CSV with a different number of columns in it. And how does that work? Well, in a relational database management system, it could work, but not so easily just directly on file structures. So the typing information, I think, is also really valuable, because when you know, if you just have things in text, it's not going to be as easy to work with programmatically. And when we have a schema, though, if we have a schema that checks those sorts of things, then you have other attendant problems, because you have to worry about how does the schema migrate over time. And that has implications to the code that ingests and modifies and deals with it as well. So at minimum, I think, you know, we need some sort of revision control. So here, Git could work for you. You want to be able to scale to the data set sizes that you're currently looking at. So you should see if your tool can scale up to whatever it is that you're looking at. And it will depend on what kind of problems you're trying to solve. Provenance, authorship, commit time, pipelining. I think this is something that in an ideal system we want to see more of. And then this, you know, safety, the branch and rollback. And then I think also collaboration is you know, what made Git so much better, what allowed it to do a lot of these sort of pipeline-y type actions. So I think we really need to look into having push, pull, and clone. And the ability to clone a database is pretty powerful tool, because you can, you know, to branch a database, you can take a database, play, you know, the one that's in production, you can, if you can do a fast clone of it without having a lot of difficulty, then that gives you a lot of advantages to playing around with the data. You can do other things with it than you were doing previously. Then change management, merge. Now merge on data is hard. It's hard on code, but code has small numbers of lines. It's hard on CSVs, but once you start going to structured data, merge is just very tricky. And it will remain tricky because it is just fundamentally a hard problem. So you need to give tools that help people to resolve merge conflicts on large amounts of data that has structure. And that involves, again, going back to the schema control and the ability to discover using query. And I think finally, like end-to-end encryption should be something that is really important when you're talking about collaboration. So lots of, like, data is the new oil, so you don't want everybody having it access to it.
You're not allowed to say that. Git for data, data's the new oil.
Data's the new gold or something. Somebody was saying data is the gold or something. I don't know.
Yeah.
Data's the new Bitcoin. I don't know.
The new Bitcoin.
Well, Gavin, real fast, I mean, I don't want to derail you too much because I know we don't have that much time, but can you talk a minute about why merging is so difficult?
Yeah, so I don't know, like most people have experienced merge conflicts in code, and that's just with lines of code. And the problem is that the context is not understood by the merge algorithm. The merge algorithm just tries to figure out, maybe I'll put these here and that there, and it'll all work out. So if you have a schema, you can actually do much more intelligent things. And I think eventually code's going to go this way as well, because if you knew what the AST structure should be or what is allowable, a lot of those merge conflicts will just go away because it's obvious that that's not possible. that there's going to be, you have to choose this one or that one, but not both, because you can't have 12 arguments in this function because this function only takes 3 arguments. So that kind of information is just not apparent, and we've just dealt with the problem by the fact that there's not that many lines. That's how we've dealt with it so far. And like there's different merge algorithms that Git has. They're very clever, but they're guesses, and they're not the most sophisticated guesses. They know nothing about the structure.
Awesome.
Yeah. So that's
it really happens when you get into large data as well. So if you've got like just a very large number of merge conflicts, like 50,000 merge conflicts, like how do you visualize that? How do you work with that? It's a tough problem, and it's kind of one that we're grappling with in general.
That's right. Yeah. And so like if you have a schema though, at least you can suggest certain kinds of things, and like you'll know more about it than you did with just lines of text, but still 50,000 choices. How do you make 50,000 choices? You're not going to be clicking down through each one of those by hand. You're going to have to survey a number of them and then do something programmatically to resolve them.
And we've got a question coming through here in the chat from Karsten. He's saying, to get from one data commit to another, you need to apply some transformations like a SQL query. Have you thought about versioning these transformations and merge these instead of the data for a merge?
Yeah, so that's an interesting question. So there's a tool out there, I can't remember off the top of my head, but that just stores the changes in terms of query that have taken place between different commits. The transformations that we make are quite simple. They're like delta encodings that Git uses. So we actually store the change to the schema and the change to instance data, all of the things that were added, all of the things that were removed in both the schema and in the instance graph. And that's how we do those transitions between them. You could also store all of the transition functions that caused you to move from one to the other. And like I said, there is a tool out there for SQL that does do that. It also is not necessarily as easy to figure out what it is that's happening, because you have to know the coupling of the commit that it happened at and the transition function, and then evaluate that. But that is certainly a way to do it. So yeah, so I'm just ending here, I think. So this is my last slide. It's just about machine learning and revision control specifically, and what I think is important. So I think like we want to be able to store data logically in our actual programming environments. So a lot of times we're not storing it logically, we're storing it what's convenient to be loaded by the processing algorithm that we currently have. And I think a lot of times it was awkward for me in my personal experience to have to store it in a database that had a lot of different relations, etc. But in the end, that was probably better than just trying to keep track of the CSVs for the load, because that data needs to be updated on a regular basis. And so there has to be some sort of extraction, and that extraction has to come from somewhere. And so when that data is updated, it's better to have it in some sort of database oftentimes than not. And I think the easier we can make it to ingest directly from a more logical point of view, and then XGest, so the ability to take whatever it is, our labeling, et cetera, and enrich the data environment in the database with what our outcomes are, then I think that's going to prove to be a better way of doing operations. And I think branching helps here, because you can do experiments and you don't have to pollute somebody else's environment. And then if it turns out that it's good, then you can convince your team or whatever, and then just put that into the pipeline. And that would be the way I imagine these things work in the future, or perhaps in the more advanced uses of Git that people might already be doing. And that's, yeah, and so I think, merging back predictions into whatever it is that we're using those predictions for is where we want to make it smooth as well. And that's basically my spiel.
This is awesome. This has been incredible. I have one last question for you, and I know time's up, so people may start dropping, but are you guys fully focused on machine learning? Would you say that that is the primary use case, or is there other use cases you feel like are useful?
So we're definitely kind of broader than just machine learning. So like we see a lot of useful use cases. Like I suppose for us, we're looking for anywhere where people really care about curated data. And they care about, you know, the value that's in that. So data engineers and machine learning engineers are, you know, two brothers or sisters from, you know, different mothers, as they say. And so anybody who's got those kind of data engineering, integration, management challenges with a messy data science team, you know, we're focused on those sorts of use cases as well. So it's kind of across those two different branches of the same family.
Perfect. Great. Well, Luke and Gavin, thank you all so much for coming on here and joking with me. And for everyone that would like to check out any more info on you guys or just connect and continue the conversation, you are in Slack. You're also on LinkedIn. I know that. And it's terminusdb.com.
That's it. We used to be on Slack, but we took the step up and we're now on Discord.
Oh, you have your own Discord. I was saying you're on but you are on the MLOps
we are.
community.
We have a community Discord as well, that server.
Cool. So if people want to get cracking, it's all open source, right? So they can have a play with it. It's really cool to see and really nice to see how you're thinking through these problems. I really appreciate you saying what your vision is, because like why you feel there could be something better and how this utopian world would look in your eyes, especially what you were talking about there at the end, Gavin. So and then also telling us what the landscape looks like, Luke. So everybody, thank you for joining us and staying until the end. If you are not in the MLOps community Slack, jump in it. If you're not following us on all of our social networks, I'm going to do another shameless plug and tell you to go get on there, like it, share, subscribe, whatever it is, whatever it takes. All right. That's it. Luke, Gavin, thank you again.
Great.
Cheers. Thanks.
Later.
See ya.